presentation before the morning break, which will take place at about 10 to 10. And then we'll reconvene here for the second part of the morning at 10:20. So please go ahead, Cécile.
Thank you very much. I'm glad to be with you today. I'm going to focus my presentations on application steering engineering with SD-WAN. Because with SD-WAN, we all speak about multiple WAN links, but how to use them efficiently. So I will divide my presentation into 3 parts. So first, I will focus on application visibility. Then I will speak about the different methods we have today available to make some performance measurements. Then we will see how we can redirect applications on the right path according to the performance of each WAN links. But first of all, I would like to speak and to say a few words about Interdata, because I'm sure that most of you don't know us, so you don't know who we are and what we do. So we are specialized in network integration for more than 3 decades. We are focused on the French market, and we are well known to provide optimized, highly available and secure telecom networks to our customers. We are used to provide innovative solutions to our customers based on emergent vendor today. So 5 years ago, we started to work on SDN and NFV technologies to automate and orchestrate the network of our customers. And today, we are focused on SD-WAN technologies. So we built the first mock-up in 2015, last year, to show this technology to our customers. So we are able to provide several solutions and to help you in your choice. Okay, so we act as a consultant, but not only, we are also able to provide services and the highest level of support and services around this technology. And I don't have to forget, we have a subsidiary called Cecile, really focused on performance measurement and metrology, so that's why it's linked with my speech today. So just a short slide just to show you who are customers and who we address. So of course we work with carrier service providers, but also with enterprise in the financial or media market, as you can see. So, but we are here all in this room today to speak about the WAN evolution, because WAN evolution is back on the table today. So why? Of course, we all speak about this before, but we see the cloud explosion. So the company are using more and more cloud services. It can be like a software as a service, or also IaaS, so infrastructure as a service. We also have we see also the traffic growth on the WAN networks and the user experience degradation. For example, companies are pushing more and more for video conference to limit trips. In green IT philosophy, they try to push for video services, but we speak about high definition videos, so the impact sorry, the impact on the WAN and on the bandwidth is pretty important. So the traditional network, as we see on this diagram, with the proper data center is not up to date now. The hub and spoke technology is not up to date. So the legacy WAN inhibits the business transformation of the company. So it's very challenging now to change the one network to be as agile as we have in the IT. Companies put a lot of focus on, for example, server virtualizations, hyper-conversions, DevOps, but they put less energy on the network. So now it's the time of the network to be changed and transformed to be compliant with the agility of the business. Okay. So as a consequence of this new behavior, I just give you some number. It was provided by one of our partners, Versa Network. So the WAN bandwidth continues to grow between 20 and 50% annually, and around 80% of traffic carried over MPLS VPN is internet today. And also video conferencing traffic increases by 400% per year. So the first step that we see in companies with our customers is they add an additional link, an internet direct access to their VPN and traditional IP/MPLS VPNs. First of all, they use it as a backup. So it means if the traditional VPN there is a failure on the traditional VPN, they move and they switch the traffic on the backup link, or they can use it also like a local breakout. So it means they send internet traffic directly to the internet direct access and the critical applications on the VPN. But all this is static, and it's determined by traditional equipment like routers, firewalls, and you need to have manual configuration. It's not dynamic. So now with the SD-WAN solution, you are able to have a unify and create a unify and secure ones across multiple VPNs, and the VPNs can be Ethernet or Internet, or IP/MPLS. And you can select your applications. You can select the path according to the critical level of your the criticity level of your applications. So it's a dynamic SLA-based applications traffic engineering between different links according to the quality of the link. Because all these links don't have the same quality. They don't have the same service level agreement, the same level of availability. So it's you need to measure it in real time to send your application to the right path at a given time. Okay. But first, to do that, you need to have a good visibility on your applications. So you need to know how your WAN links are used before sending to the right path. So. Most of the SD-WAN solution, they rely on DPI engine, so Deep Packet Inspection Engine, because you have thousands and thousands of applications, and most of them are encrypted. So you need a strong DPI engine to detect these applications and to differentiate these applications. So here it's an example with a reverse screenshot to be able to recognize as many applications as possible. Because, for example, if I look at Microsoft Link, you have voice traffic and data traffic, and they use both traffic. They use the same IP address. They use the same ports. So to differentiate, you need a highest engine to detect these applications, because you might want to send the voice traffic to your VPN, IP/MPLS VPN networks, and the video traffic to the internet, because it does a better job with the latency, jitters, and everything. In addition to that, to have a full view on your WAN traffic, you might want to customize your application. So with some SD-WAN solution is possible. So here it's an example where you set the application types, you set the criteria for this application, the device group, the source, and you can define new applications which are not defined in your DPI engine. After, it's interesting to group your applications, because you are going to to apply policies not by application per applications, but per group. So here it's some example. For example, business videos that you want to send to the internet, like FaceTime or Microsoft Link video, or another group like business productivity with email messaging. It's a way to select and grouping your applications to set a policy per application and per group of applications. But before speaking about policies, we have a view. Sorry, we have a view that a kind of visibility you can have on the application. So here it's an example from a Versa network, where you see on this graph the top applications or top URL used during a certain period of time. And you can have some analytics and some reports about the ability, a bit like we do a next generation firewall. So now you have a good view on your WAN network and the traffic on your WAN network. So now you need to measure the SD-WAN performance. You need to be able to measure the performance of each one link, because when you design a SD-WAN solution, of course, the cost reduction is important, but you must also improve network performance. And between any 2 points, you need to have the visibility on the latency, on the jitter, and congestion. So when I speak about metrics, I speak about delay, so the latency, the delay variation, so as we call also the jitter, the loss, the availability, but also you need to measure per forwarding class. And this is important because in some kind of IP/MPLS, the VPN, sorry, the delay is dependent on the class of service. So when you send a test packet to measure your performance, your test packet must be similar to your application. So the class of service field, like the VPT field, the TOS field, must be marked as your proper application traffic. And then based on these metrics, you will be able to select the right path according to the criticality of your applications. And you can also make some reports and analytics about these numbers. So what are the tools available for these performance measurements? So you have a well-known protocol based on IP SLA. It was initially developed by Cisco, and it's usually used to measure performance on layer 3 IP VPN routing networks. It's a real-time application protocol based on ICMP protocol and defined in the RFC 2925. With this protocol, you can set several parameters to make your test packet as similar as possible as your application traffic. So you can set the time interval between two measurements, the number of packets sent during a set of measurements, the time interval between 2 packets, the packet length. So it's very important also because for voice over IP, for example, we have a short packet, so you want to be conform with your traffic. Of course, as I said, you can set layer 2 priority field and layer 3 priority field, the SCP, and also the timeout, and you can set the availability of your link with this, the timeout. But there is a second set of protocol, which is called Ethernet Service OEM, and defined by the IEEE 802.1 called also Continuity Fault Management, and the ITU 1731. These protocols are today mainly used on layer 2 VPN services. It was defined by it's pushed, sorry, by the MEF, the Metro Ethernet Forum. and it's roughly used since 2007 when carriers started to launch layer 2 VPNs. So with the 802.1 AG, you will be able to define the availability of your link. So it's between two endpoints. The endpoint exchange a continuity check message, and they can detect the loss of continuity if you have no response of your of the remote point. And the ITU Y1731 define packets for performance measurement, and you can set the packet as we can do with IPSLA. Okay, so here it's an example of configuration. So you see it's a screenshot from Versa network. So as a per class of service, so best effort and expecting forwarding, you can set the monitoring interval and logging interval. Of course, all this measurement can be logged, and you can generate traps according to some threshold. So the key SLA metrics that we are going to measure, it's the frame loss ratios. So it's the percentage of service frame not delivered divided by the total number of service frame delivered in a T interval. It can be forward or reverse. You have the frame delay, so the latency. So generally, it's it's a two-way delay. The frame delay variation, as we call also the jitter, so it's the variation in frame delay between a pair of service frames, and the availability, it's a percentage of time the path is in a connected state. So I give you an example here with the Riverbed SD-WAN solutions. So here it's they provide the path quality window. It's between two points, and here again per class of service. So urgent, high, normal, and low. You can see the throughput, outbound, inbound, and the path quality defined by the latency, the jitter, and the packet loss between any two sites. Another view with a Versa network with a network performance visibility. For a selected period of time, you are able to measure here on the screenshot the delay and the loss ratio over a period of time, and below you have the number per quality of service. You can see the key metrics that we defined before. So now we have the visibility on the applications. We have the visibility on the performance of each one uplinks. So we can redirect the applications according to the quality of the path. And we can do a true application traffic engineering based on the time of day, the link priorities, the real-time link performance, and the application requirements, considering the bandwidth, the delay, the jitter, or the error rate. Sorry. So we can, but all the SD-WAN solutions are not do this traffic engineering. There is several ways to do that. Here it's a Riverbed solution where you can edit traffic path rule. So you define the user source, of course the applications, or group of applications as we defined before. Then you select the path that you prefer, can be the internet or routed VPE. For the internet, you can have several equivalent internet paths. I mean, you can have a SDSL internet, 3G or 4G, and you can equally balance your traffic on several internet links according to your configuration. The second way, here it's done by Versa Network Solutions. You can really redirect your traffic according to the performance of each one link. So here it's some screenshot of configuration. So first you define an SLA profile. So it means you define the maximum delay variation that you want, that you tolerate, the maximum latency, the maximum packet loss. So this is your SLA profile. Then you attach this profile to the forwarding profile. here we find back the SLA business as defined previously. So the forwarding profile defines the rule for the traffic. Then you define the rules. So here on the top you see the tab. There are the criteria to select your traffic. So it can be a simple source or destination address. It can be a IP header, or it can be, as we said, applications. So here you have the list of applications or URL category. And the last tab, you address a forwarding profile, where you find, of course, the SLA profile with the maximum latency and jitter and packet loss that you tolerate for these given applications or for this given piece of traffic that you selected. So for each piece of traffic, you are able to define an SLA profile and up to the forwarding method. Okay, so here I arrived to my conclusion. So with the SD-WAN, you need to take advantage of all the WAN uplinks you will have in a kind of hybrid network. So you need, of course, for that detailed visibility about your application. So you need a strong DPI engine, the capability to define your own application if you need. You need to group these applications to set policies. Then you need good tools for past performance measurements. So we spoke about IP SLA, the IEEE 802.1ag and Y1731. And after, you can really make a true traffic engineering based on service level agreement. So thank you very much for your attention. Thank you.
Thank you very much, Cecile. Are there any questions from the audience, please? No questions? Okay, so again, thank you very much, Cecile and the other speakers for this morning.